Hello everyone, welcome to Computer Organization and Architecture class. In this unit, we will talk about the Central Processing Unit, CPU. The diagram on the screen illustrates the high-level architecture of a Central Processing Unit. A CPU is composed of two sections, including data section and control section. The data section includes ALU and registers, which handle the data computation. Registers are placeholders to temporarily hold data which will be processing or have been processed by ALU. And the control section includes control unit, which coordinates among components in the system. Running a program can be considered as cooking. A CPU can be considered as a chef. The program can be considered as the recipe, which lists step-by-step instructions. The data can be considered as ingredients. Both program and data are stored in the memory. A CPU follows fetch, execute cycle to run a program. In step 1, the CPU fetched the next instruction to be executed from memory based on program counter, PC. This step can be considered as the chef uses a ruler, a PC counter, to highlight the current step and read one instruction in the recipe. Step 2, decode the OP code, operation code. This step can be considered as the chef converts a shorthand instruction to its actual meaning. Step 3, read operands from main memory, if any. This step can be considered as the chef takes ingredients from the countertop, where the countertop indicates the main memory. Step 4, execute the instruction and store results, if any. This step can be considered as the chef follows the instructions to handle the ingredients and store the processed ingredients in a container on the countertop. Step 5. Repeat steps 1 to 4. The chef repeats these steps until the end of the recipe. We summarize commonly used ARC instructions on the screen, which can be grouped into 4 categories. The first category is memory-related instructions. For example, LD indicates load a register from memory, and ST indicates store a register into memory. The second category is logic-related instructions. For examples, AND-CC indicates a bitwise logical AND, and OR-CC indicates bitwise logical OR. The third category is arithmetic-related instructions. For instance, ADD-CC indicates add. The fourth category is control-related instructions. For examples, call indicates performing a function call, and jump L indicates return from a function call. This diagram illustrates the data path that how ALU registers and control unit work together to execute a program. The register file in a diagram can be considered as a small, fast memory separate from the system memory that is used for temporary storage during the computation. Typical size for a register file range from a few to a few thousand registers. Like the system memory, each register in the register file is assigned an address in sequence starting from 0. When you write a code in a high-level programming language, such as Java or Python, you cannot directly execute the code without compiling it. To produce an executable code, the source code must be compiled and linked with other essential libraries to produce a series of instructions, which can be executed by the machine. When running the executable code, the series of instructions are loaded into system memory. At the runtime, ALU sequentially reads each instruction and follows the instruction to handle data. It is worth noticing that on different computer systems, the instruction set may be different. Therefore, we may need to recompile the program on different systems. For example, assume you create a source code on a Windows system and compile the source code as an executable file A. The executable file A may not be executed on Mac or Linux machines due to different instruction set. Owing to the popularity of the Internet, we want to develop programs that can be executed on different systems without recompiling the source code. This need leads to the development of Java, which use Java Virtual Machine (JVM) to overcome different instruction set problems. The corresponding JVM must be installed on a system. The JVM runs the Java bytecode by translating the bytecode to different instruction sets on different computer systems. Any questions?